right, well, next up, we have Dr. Juan Hernandez-Medrano, and he is a veterinarian graduated from the faculty of Vet Med at the National Autonomous University of Mexico, and also has a PhD in agricultural science from the University of Nottingham in the UK. So his research has involved different aspects of reproduction and nutrition in both cattle and sheep, in areas such as ovarian physiology, cryopreservation, as well as fetal programming. He recently joined the faculty of Vet Med at the University of Calgary as an assistant professor in bovine theriogenology, aiming to expand his research in the area of maternal stress and the long-term effects on the productive and reproductive performance of offspring. And so it's my pleasure to welcome him here today to tell us a little bit about extreme weather impacts on female fertility. So Juan, take it away.
Thank you very much. Ooh. I think this thing moves a lot, right?
It does sometimes.
Okay, well, thank you very much and good morning, everybody. First of all, I would like to thank the organizers, particularly Dr. Kajal Devani, for the invitation. So I think there was a kind of a missing word in the title of the presentation. So as it was mentioned when in the introduction, I will be talking a little bit about what we call fetal programming, right? So I'm not a geneticist, as you heard from the description, from the introduction. And the only thing I remember from my genetic lectures was that a phenotype equals genotype by the environment, I think. That's my, as far as my genetic knowledge goes. And I guess if I have to place my research or my research interest is gonna be in that genomics or genetic genotype by environment realm, I would say. So I don't have anything to disclose, only that I work for the University of Calgary and that I am not a geneticist. So please bear with me if I say something that is not exactly accurate on the genetic realm, and please come back and ask me about it. So the plan for this lecture is pretty much, it was about the idea to talk about extreme weather events or extreme events really in the maternal life that could cause changes in fetal development, and that those changes have long-term effect on the offspring, particularly on the offspring performance. So hopefully by the end of the lecture, I will be able to present some of the results, the research that we've been doing with a group in Australia, and some of the initial studies that we're trying to put together here in Canada. Okay, so if you have to leave early or for any reason I lost you halfway through the presentation, at least I would like you to have this, the first one particularly, the take-home message that I know is really good, and we've been talking a lot, and I've been learning a lot about genetics and about selection, but just keep in mind that we are working with live animals. So the way they have this genetic potential that you are very good at selecting, but if you are not treating the mothers the correct way, then you can impair the performance of those animals that will be on the ground later on in life. So, and one very interesting point that I usually make is, particularly for beef cattle, steers, if you think about the steer, at least about 40 to 45% of that steer's life has already happened in utero. So a lot of the initial growth, the initial development, the initial differentiation of tissue happens already in utero. So that animal, when it is born and is going to live another 1 year, 1.5 years, has already passed 1 year in utero. So just remember that bit is also really important. I don't think I need to, I think we've been talking a lot about the environment, and I think I just put this one slide just trying to mention what happened last month. And these are only events last month, but I was listening yesterday to the UN Meteorological Service, and they are predicting that the El Nino, we're going to have kind of a mega El Nino in the following 5 to 7 years, which in fact, what is going to mean is that I think 2024 is predicted to be the hottest year in history. In fact, last Monday was the hottest day in recorded history globally. It was 17 point something degrees, but I guess it's the average globally. So they seem that this is going to be an increment in temperature. Okay, so these events will continue. A lot of the extreme events will become more erratic. So they are very difficult to predict now, and they are happening more frequently. So what would this really mean for animals? Well, animals are really good at adapting, I guess. Oh, well, I think, because we've been kind of selecting animals and working with animals for a few years, I guess. But before we started selecting them, they were very good at adapting to their environment, right? So if we give them enough time, they will be able to adapt. However, I don't think we will have enough time for them to adapt, especially on the current system conditions. So a lot of the changes that animals kind of implement in order to adapt to their environment might be perceived as negative for the industry production, particularly. So the other thing that I want to point out is that we are talking about changes in temperature. I mentioned a bit about changes in temperature. However, there is going to be also a change in the amount of precipitation, particularly in North America. So there seems to be an increase in drought, particularly southern United States and Mexico, for example. But again, from the report yesterday, there seems to be an increase in the drought conditions for the following 5 years due to El Niño, particularly in the Northern Hemisphere. In fact, here in Alberta, yesterday, the government had declared a drought, agricultural emergency due to drought. So there's been three years in a row, from what I heard, that had been low precipitation. So we are starting to see this combination of events. We're going to start seeing increments in temperature, which are associated to low water availability or increase in drought, which means that for our animals, particularly those that live outside in pasture, there will be usually a combination of stressors that happen at the same time. You will have high temperatures with low pasture availability. So you will have the combination of a thermal stress with a combination of nutritional stress or undernutrition. So we'll have this. And the important bit about these stressors is that they have an additive effect. So it's not, as a scientist, we tend to investigate them individually, but in real life conditions, these effects happen simultaneously and they have additive effects on the animal. So just keep that in mind. So just quickly to remind you what heat stress is, or how animals are able to cope with heat stress. Usually cattle are quite good at keeping the temperature, the core temperature, when they are around the thermoneutral zone, which is pointed there. And also now if you add, we have many other indexes measuring thermoneutral and thermal comfort in cattle. If THI is below, let's say 74 for feedlot cattle, they seem to be quite good at thermoregulating. If they are less than 68 for dairy cattle, they are also quite good at thermoregulating. And just the difference is the amount of metabolic heat that they produce. So if the animals are under production, then they tend to produce a lot more heat. So they need a kind of a lower index, right? A lot of these calculations, particularly THI, doesn't take into account the color of the animal, particularly and the wind, sometimes the wind speed. And those particular kind of parameters are very important in animals kept outside, for example, in the case of feedlots or in animals on pasture, right? So those are really important to take into account because that is pretty much the way that the animal is able to regulate their environment. So with the higher or the increases in temperatures, in global temperatures, there is a prediction that there's going to be an increase in the number of heat waves. In fact, we are predicting that there's going to be several heat waves during this summer here in Canada. And a heat wave is pretty much when there is a period of time that is above the regular average for that particular time of the year, that is longer than 5 days. So it could be weeks, could be months, but it's longer than 5 days is considered a heat wave. The problem with this is when temperatures go really high and during the day, but then during the night, temperatures don't really cool down. The animal has this, or in fact, the heat has this cumulative effect within the animal. So the animal tends to accumulate heat. So the animals tend to go into heat stress easier than they will go if there is a chance for them to cool down. The problem with this is that this heat load, this increase in the heat load of the animal will cause that the animal or the impact on production or the impact of the animal physiology will continue even months or sometimes even years after the heat wave event happens. So this is kind of a cumulative effect, but that would have long-term effects in the future for the animal. And now we will hopefully explain that that will also could affect their offspring. Okay, so I think everybody here will know or will have a kind of a very good idea what happens when an animal enters in heat stress. The first reaction is usually going into an increase in respiration rate. Of course, then they start panting. That's the most common one. Temperatures start to increase. Once temperature starts to increase, there is a change in endocrine change. Most metabolic hormones tend to decrease, and most stress hormones tend to go up. For example, adrenaline or adrenaline and cortisol, they start going up. Remember these hormones because they are quite important for fetal programming as well. So when the animal, the other characteristic is that the animals start decreasing in intake. This is a kind of an adaptive reaction in order to decrease metabolic heat. So if you stop rumination or decrease your intake, stop rumination or slow down rumination, you start producing less and less heat. Therefore, you don't need to dissipate that much, but your cardiovascular system starts to push blood towards the extremities or towards the outside of the body, leaving some of the core organs, decreasing the blood flow towards some of the blood organs, and that one also intervenes in the digestion or decreases the digestion of some of the nutrients. So this, of course, has an effect on health and immunity, and particularly for me and my interest, it pretty much shuts down reproduction. So when an animal is in heat stress, similar to when an animal is under nutritional stress, under extreme nutritional stress, one of the first things that shuts down is reproduction. And that is something, because reproduction is not an activity that is necessary for the survival of the animal. So sometimes when these animals go into extreme stress, they usually shut down reproduction very easily. And that you can see that in the males when there is a change in the spermatogenic capacity. So spermatogenesis pretty much is impaired. And then you have this effect later on in life that you can see still in the semen of these animals. In the case of females, it's really interesting that usually what happens is that the folliculogenesis, so the ovarian follicular development and luteal activity is impaired as well. So animals either don't ovulate or they really, the follicular growth is completely affected. That affects oocyte quality and therefore fertilization and embryo formation. So you have usually early embryo losses. That is if the heat stress or whatever stressor is taking place during early pregnancy. If that happens during different stages of pregnancy, it can have some other different or alternative effects. For example, in this case, one particularly described for dairy cattle is the decrease in uterine blood flow. I described how the cardiovascular system works when animals are under heat stress, and in this case, the uterine blood flow is reduced. So the theory, or one of the observations that we have, is that if you reduce the blood flow to a pregnant uterus, you decrease the amount of nutrients that are given to that, or that are available to that fetus. So you can impair the development of that fetus. How bad or how impactful can be this change or changes in increases in maternal stress or maternal stress events? How impactful they can be for the fetus really depends when they happen. And I think, I don't know, I cannot point out, but yeah, if you see here, pretty much all organs are developed between the first and second trimester of pregnancy in cattle. All the tissues and organs are usually differentiated and developed at that point. From the let's say late second trimester, third trimester, that is when the exponential growth of fetus that you see. So this is really, really, really important for us, in reproductive physiology, because all the formation, particularly the formation of of the ovaries takes place during, let's say, half first trimester, half second trimester. So that between about day 50 to day 100, 120, the ovary and the testes are developed. So if anything happens at that point that can impinges on the availability of nutrients on the availability of this fetus to develop the ovaries, it will have a long-lasting effect in the offspring. The reason is because, at least for heifers, the heifers are born with the number of follicles that they will be able to ovulate throughout their lives. So once that number is established in pregnancy, it cannot change, or it doesn't really change after that. It only decreases. So that's why this is really important for us in reproduction. So I think some of you have come across to this theory of DOHAT, the developmental origins of head disease. This was developed for humans, but now we are trying, well, in fact, we have enough evidence to say that this is also happening in animals, especially in livestock animals now. So just a commercial here, next year I think it's gonna be around July, in the SSR that is gonna take place in the SSR meeting that is gonna take place in Ireland. There's gonna be the first meeting on this DOHAT for livestock. So if you are interested, please let me know. I can point you out who is going to be organizing it. But it's gonna be about fetal programming and the possible effect, or the effects that are already described in livestock species, particularly cattle. So we know that a lot of these changes that I've been talking about that can happen during these different stages of pregnancy are usually driven by the placenta. So the first thing that is affected is the placenta. Remember that the placenta is kind of the interface between the fetus and the mother. We always tend to forget a bit about the placenta, but the placenta is the one that drives fetal development. And the way that the placenta is developed, it can have an impact on how the fetus develops. So the placenta, if you see it that way, the placenta kind of translates the environment that is the maternal environment for the fetus. Okay, so the placenta tells the fetus if it needs to adapt its metabolism, if it will need to adapt or it will increase or slow down the rate of growth, just to make sure that this animal will be able to survive. So the main principle of the placenta is to allow fetal survival, and the placenta will program or will kind of reprogram that fetus or stimulate the programming of that fetus in order for that one for the fetus to survive in utero and then adapt to the environment that is outside when it is born. So all these things happen at this level, and particularly it happens without any change in any genetic in the genome of the fetus. So the genome is the same. So whatever you select for that animal to be, so let's say you have the high genetic value female with the highest genetic value bull, that genetic value for the fetus is going to be the same. This is probably the highest that you can have. Now, will the fetus be available to express that genetic potential? That can be hampered during the fetal growth. So you can have everything in place, but by these mechanisms, and I'm sure a lot of you are already familiar with epigenetics, which are changes in gene expression. So this epigenetic can switch on or switch off some genes, or make sure that the genes are never expressed because of the way the chromatin is organized, or they can silence once the gene is expressed, they can silence that mRNA produced, can be silenced at any point. So even though the fetus has the capacity to do that, because of the environment in which it is growing, those signals can be stopped and therefore never expressed. Okay, and there is a change in what happens in the development of that fetus. Okay, let me just take a bit of water. Okay, so I've been mentioning a lot of what happens when the animal is pregnant. When you subject a cow, let's talk about bovines, you subject a cow to any stress, either a thermal stress, or a heat stress, animal under heat stress, or animal under nutritional stress. And she's pregnant. So if she's pregnant, then you have a direct effect on the fetus, and it's very easily kind of understandable because of the placenta and all the interactions that I mentioned. However, we now know that anything that you do to that cow can have an impact even if those stressor situations take place even before that fetus is conceived. Probably I don't know if you have heard about this concept of periconceptional programming, and the periconceptional programming or periconceptional period is pretty much encompassing from about minus 60 days of pregnancy of AI, the time that you're going to do AI or the conception, minus 60 days to about 60 or 90 days, depending who you read. And during this period, all these events are taking place in the cow. So the follicular development that you see on the graph on the left, that follicular development, in order to produce that follicle that will ovulate, produce the oocyte that then can be fertilized to produce the embryo that eventually become a fetus and a neonate. That last stage, the development of the follicle from the activation at the stage of primordial follicle to ovulation could take between 3 and 4 months. So the only thing that we tend to control is those last 10 days. So we can hormonally and reproductively control those about 10 to 12 days, like the last formation of, or the kind of the final stages of folliculogenesis. However, during all the process of the follicle growth, or that oocyte that is contained within the follicle, this oocyte is gaining a lot of markers, a lot of genetic markers, particularly methylation markers, which are these markers that are able to switch on or switch off genes during during fetal formation. So if the animal is subjected to a nutritional stress, to a low nutrition and undernutrition, now we know that this changing the diet or having a very low protein diet during these stages of follicular development can have a long-lasting impact in the fetus, and hopefully I will show you in the next couple of slides. So this is pretty much a summary of what I just said. Whatever you do to that cow, the way that you manage that cow, the way that the environment of that cow is kept before the animal is even conceived or is even inseminated or is put with the bull, that environment previous to that can have a long-term impact in the offspring reproduction. So we are not talking only about the effect directly on the mother that we already described, but the effect that it can have on the long term. We know now that both heat stress and maternal stress can have an impact on fetal growth. That's very simple. So if you decrease the protein content in the diet, and I'm just talking about this bottom graph on the left, that is the biparietal distance, so the size of the head, let's say, of the fetus. So we measure that as a kind of proxy of the size of the fetus, how the fetus grows. If you see that, if you change the diet of those animals before the animal is conceived, from we are comparing 7% protein versus 14% protein, kind of crude protein, that's pretty much or treatment usually, or treatments. So you see that there is a decrease in the size of those fetuses, right? So there is a decrease in the size of the fetus just by subjecting that animal, that mother, that cow, to a low protein diet before that fetus is conceived, okay, in the periconception period. Also, we have observed that there is an effect directly on organ formation. And if you remember the graph that I showed you earlier, it's pretty much kind of expected, right? If you are affecting the maternal environment during the first trimester of pregnancy, a lot of the differentiation of these tissues might be slowed down or might be hampered. So, for example, in this case, we observe. I'm just presenting the information about the heart, just kind of continuing with the heart long talks that were done yesterday. So we've seen that when you subject animals to low protein diets during the periconception period, you have a differential effect on males and females. Usually males are more affected, and the sizes of several of the organs are decreased. Among one of those is the heart in the female. So the heart in the female, the heart in the fetus at the end of the first trimester is decreased in size by only changing the diet in the mother 60 days before it was conceived. So it can have long-lasting effects on this. So another thing that I want to point out that is in here at the bottom, and is about birth weight. A lot of the studies that we've done with nutrient restriction or with maternal protein on their nutrition, we observe that if you have an issue with that cow, or there is an undernutrition of that cow in the periconception period, going to the first trimester of pregnancy, you won't see a change in the birth weight. So birth weight is going to be similar to animals that were kept on the correct conditions, let's say. So birth weight is not a very good proxy, or is not a very good indicator of estimating impact on fetal development when the cows are subjected to any heat or nutritional stress, particularly if those happen during the first trimester. Once you move into the second trimester and the third trimester, then you will start seeing these effects on birth weight, because you are affecting fetal growth at that point. So fetal differentiation during the initial parts of pregnancy, you won't see any effects on birth weight. But if you change, or you have a stressful situation, or stress factors towards the end of pregnancy, you will see changes in fetal weight. And this one has a lot of information, which I will not review all of it, but the only one that I want to point out is, particularly for me, reproduction is one of the most important bits, because a lot of animals are culled or removed from the heads on the base of reproduction. So as you see, even preconception diets or periconception diet can affect the age at which these animals reach puberty. So they tend to reach puberty a bit later on. This is particularly true for the bulls. So the bulls tend to have a similar scrotal size, but the sperm quality is reduced in these animals that were conceived from, or that were born to animals subjected to nutritional stress at this point in periconception. And also we have, as you see, I cannot point that, but on the reproductive column, you see that there are several gaps in there, which that is kind of my objective now, to start filling that information there, which is that we now know that affecting the diet during the second trimester now and during the first trimester from studies in other groups, you can affect the number of follicles that are developing those ovaries. Why is this important? Is because it's linked to fertility. Okay, so that was nutritional stress. What happens to heat stress? I'm trying to establish some research on heat stress here in Calgary. And I started working with my students and some colleagues, trying to do initially a scoping review of what is out there, right? So this is pretty much what is out there. The first thing that jumps out on heat stress and fetal programming is that a lot of the research is done in dairy cattle. A lot of the information is on dairy. And a lot of that information, information coming out of heat stress is during the dry period. So these animals are only subjected. So this is a comparison between animals subjected to during the dry season to either heat stress or non-heat stress animals. So either heat stress, they are either not cooled or cooled using fans or water spray or whatever treatment. So this is kind of just a summary of the effects. And you see that what I mentioned, that if you change, or if you have an effect of during the last trimester on the mother, you have an effect directly on the birth weight. So you are affecting the growth of the fetus. And also, interestingly, they have also found that there is an effect on the development of several organs if you change, or if you subject animals to heat stress during the dry period in dairy cows. The highlighted in red, highlighted text in red refers to reproductive parameters, which I'm interested in. And as you see, similar to what happened with nutritional stress, You also have effects directly on age at puberty. So animals reach puberty later when the kind of the daughters of those animals reach puberty later in life than those that are not subjected to heat stress in utero. And also, if you see, a lot of the reproductive parameters are affected. Either the conception, calving to conception rate is increased in dates, the percentage of repeaters or rebreathers is also increased as well. The service per conception is also increased. So there is something in those animals that is becoming more difficult for them to reproduce, right? And then if we see to the last three words there, AMH, anti-Müllerian hormone, AFC, antral follicular counts, and ovary size. Anti-Müllerian hormone is a marker of fertility. We use that as a marker of fertility of the ovarian reserve, the number of follicles that are present in those ovaries. The antral follicle count is the number of follicles that animals usually develop, which is also linked to fertility. Both AMH and AFC are associated to fertility. So now my working hypothesis is that when you affect fetal development during early stages of pregnancy, particularly during the development of the ovary, you will have a long-lasting effect in those ovaries, in those heifers, in the ovaries of those heifers, that will not cause an infertility. So we know now from these studies, for example, the one on the bottom with MOSA, the Irish group, on AMH levels, and some of our studies modifying the fetal environment, we know that we can reduce the number of primordial follicles, the follicles that are forming that ovary. But we also know that those animals are not infertile. So the first, second breeding season, those animals pretty much are as fertile as any other of their contemporaries. But you see that some of these animals, in later reproductive seasons, they start drifting slowly. So instead of becoming fertile, completely infertile, what you see is that some of these animals start becoming more difficult to breed. So instead of using 2 or 1 insemination for the animal, you start seeing that they start using 1.5, 2, 2.5, 3. And what is happening is that these animals slowly are kind of drifting away. And this has been reported previously in sheep for when you modify or when you change the number of primordial follicles present in those ovaries. So if you reduce the number of follicles that are developed in those ovaries, every time the animal goes into estrus, select several of these. So it starts running out of follicles. As the animal ages, the number of follicles is reduced. So the fertility of that animal slowly starts drifting away. So it's not that the animal will become infertile, it's just that they start becoming, let's say, they start showing a bit low fertility. Okay, and this is a slow process, particularly for the ovary. So this has an impact on longevity, as we saw on some of these on these slides, and that's pretty much what I wanna the thing that I wanna study here. How much of this impact of maternal stress that happened years before that can have on the actual heifer, the replacement heifer, and how will that affect its stability or its longevity in the herd, right? So if you have animals that are not well managed or that are subjected to these heat waves during these hot summers and they are pregnant in the first trimester, how much of these animals, the daughters and granddaughters of those animals, remain in the herds later on, and at what time they are called, and if that pretty much fills this theory that you are affecting the formation of the ovaries. Okay, so I know that this has been most kind of a very quick overview or review of fetal programming. So I have shown some examples here and there. So hopefully I haven't confused you enough. But if you're confused, please come and ask me any questions. What I would like to say is, I hope that at this point, at least you kind of have that in mind, that you can select animals. You are very good at selecting animals, but you also need to remember that you need to treat your pregnant animals well. Otherwise, those animals won't be able to express the reproductive potential or the productive potential, for example. And that this can happen even before the animal is conceived, before the fetus is conceived. So changes even before that can have long-lasting effect into the life, the productive life of those animals. And just remember that birth weight is not a very good proxy of fetal impacts unless it's happening after, during that exponential growth curve in utero, okay? Also, then this is probably more for my physiologist or my biologist inside, which is that this is an adaptive strategy. So the animals are adapting to the environment. So this is not bad. The animals are surviving the environment. We perceive them as bad because we need them to produce more. But these animals, by surviving and being able to adapt to these changes, means that they are able to kind of quickly adapt to any changes that we can put them through. There are no changes in the genetics, but there are changes in the gene expression. So what you can see, the phenotype that you can see might change depending on how you treat those animals in utero, for example. And I didn't talk about transgenerational a lot, but there are few studies, particularly in beef cattle, I think one in Nebraska and one in Montana, which they have been following animals for a long period of time, subjecting them to nutritional stress, I think most of them. And they have seen that initially, what happens is that the fertility tends to remain similar, and then slowly, as I said, slowly things start drifting away. But the other interesting observation that they have done that pretty much ties up with what they were talking yesterday in the first two lectures, the first two sessions, was that animals, when you leave them like that, when you start selecting in that way, they select themselves and they start becoming more of a mid to small frame, but they start keeping the increasing weight. The average daily weight gain seems to remain similar, and also the fertility seems to recover. So if you allow the animals to adapt, they adapt. But if you push them, usually what happens is what we saw there. So the other thing that I didn't present a lot, but I hope it was kind of obvious from some of the comments, is that there seems to be common pathways. So all stressors, as we said, all stressors have an additive effect. So stressors seem to be additive, but there seems to be common pathways to all stressors. So that is a good news, because that means that if we can identify what happens and what is really going on there, which we are getting there slowly, we can have common solutions for those problems. So we don't need to say, okay, your animal is on the has underwent undernutrition, protein undernutrition. So now we need to correct it, and because this is a nutritional stress, we have to use this strategy. Because if it is a heat stress, then you have to use this strategy. So there seems to be common pathways that we can directly target to control some of them. And some of those have been described already, and they are more coming up. The other interesting bit is that a lot of the environmental impact of this is not the direct effect on the mother or on the mother itself, is the effect that these animals, the costs really are in the indirect effects of those animals. How much does it cost for that neonate or that fetus not to express the reproductive potential? Is very difficult to measure, but it's something that we are trying to attempting to do. And then just trying to balance the research, right? Because there is a lot of research, particularly on heat stress on dairy, but not much on beef. So that's something that I think we need to look into. And thank you very much again, Megan. And I think I left enough time. If you have any questions, please fire away.
Thank you, Ryan. My microphone. Do you have any data on the effects of high temperatures, sustained high temperatures, on animals of different colors? The difference of...
Yeah, or not on fetal development. I don't think that one exists yet. But there is a lot of research done on that, and I think they have found that, at least in terms of heat load, animals with black hides or darker hides tend to enter heat load quicker, so they are less able to kind of control their temperatures, and then those effects are long lasting, so are longer lasting than it will be in other animals. So productively they are less efficient, let's say, just by that particular event. So I haven't seen a particular experiment on that in beef, but from the data that is around and the previous data that we have obtained, we will believe that there is an effect. So heat stress will be affecting nutrient availability just by the way the animal, the cow will need to adapt to survive that. And if you see decrease in dry matter intake, pretty much decrease in any nutrient activity or nutritional activity, you will have a reduction in growth, will have a reduction in nutrients. That if that happens during the periconception period, will have an effect on the formation of that oocyte. That's a theory. I don't know. It has been proven. It has been proven in mice and I think in sheep, but in cattle or in other kind of larger species are more difficult. But I believe that could be an effect, and of course the same effects will happen during the first trimester. And again, animal models have shown that, but in livestock it hasn't been studied as such, as far as I know. But yeah, hope I answered that. Yeah.
I have a question for you, and then maybe a follow-up question for Andre.
Yeah.
I'm really trying to get my head around this whole epigenetic effect, or environmental stressors and its impact on that fetus and throughout the rest of its life, and potentially on for multiple generations.
Yep.
Did I understand you right?
Yep. Yeah.
Is that potentially our creator's design for survival of the species, so that some genes or productivity levels are turned down to better adapt for survival with less nutrients or higher stress levels?
Yeah, and that's pretty much so. Animals, so that's pretty much it, right? So all the changes that we see in those animals are really adaptive changes, right? So evolutionary, these animals have developed those strategies to do that. So if you see it from an evolutionary point of view, if you are trying to adapt to an environment that is changing, the first thing you need to do is survive. Otherwise, you won't be able to transmit your genes, right? So what I see is that the epigenetic strategy comes at that point. So the animals need to survive first to kind of adapt to those new, select which of the, in this case, for example, which of the gaining or the reproductive parameters are useful in the long run. First of all, that, so they can survive. Once they have start to switching off and switching off genes, then if those markers are very good for survival, then they will be transmitted into the following generations. And eventually we will see a changes in the genetic composition of those animals. But initially the adaptation, the kind of the drive to adapt to that very quick change is going to have to come from a faster response system, which is what we understand epigenetics could be. So I hope I answered the question.
Absolutely, very helpful. So Andre, to follow up with a DNA question, how do we account, to make our genetic prediction as accurate as possible, how do we account for epigenetic effects where the DNA says these genes are here to reach this level of induction, but due to epigenetic effects of that fetus, or maybe even its parent in the developmental stages, may not, those levels of productivity may not be able to be expressed because of this epigenetic effect. How do we compensate for this? If the DNA test says it's there, but it's not able to be expressed?
I think that's a good question, and different sources of information, right? And I think the presentation, if you're looking into the epigenetic and methylation and or those intermediate kind of omics metabolites that we can try to measure. I think that's what we're trying to get at. How do we measure these other things, right? Because the genes that are segregating in the population is part of the story, right? But then you have all those other components. That's where the methylation and all those other kind of things that play into the expression and regulation of those genes that play a role into how those animals express a phenotype and respond to the environment. And so I think by measuring those things and trying to relate those to phenotypes that we can easily measure is a way for us to try to understand how that works and relate to production environments.
And I think that comes back to the only equation that I remember from genetics, which is genotype by environment, right? A lot of that is interaction.
I'll ask a question on cold weather, Chris. Not cold weather, but extreme cold weather. 30-degree weather, blizzards, extended period of time, 2 weeks at a time. What type of effects will there be above and beyond for see increased birth weight, larger cow size? What type of
You nailed you kind of nailed the nail in the head pretty much. I don't know the expression, sorry. But you are sorry, but yeah, you are right. So strangely enough, I've been looking. So if you see the kind of my objective is to look into thermal stress, so heat and cold stress, particularly in this area of the world, right? Cold stress will be very most important than heat stress probably at this time of at this point. Strangely enough, a lot of that research pretty much stopped in the 60s or 70s. I think there is not much new done. A lot of the information that I have is circumstantial, as the way that you say. So a lot of the animals that are born usually during winter, between probably February, March, they have these probably February, March, January, February. They are having this later stage of development, of fetal development in utero under very cold or extreme cold conditions. So, and this is just a theory because I haven't seen studies done in that, but what I believe is the way that the animals thermoregulate when there is in heat stress, they tend to move blood away from all the organs, right? But when it's cold stress, they do exactly the opposite. So the first thing that I would like to know is that uterus getting more blood because of that strategy? If that is the strategy if that is that is true, that means that probably availability of nutrients for that fetus is increasing. So the fetus and the placenta are already kind of extracting a lot of the nutrients from the mother, and therefore that fetus have a better growth during that exponential part, right? So the animals are growing faster and are growing bigger. Now, I would like to know, I would like to do some research on how the dystocia, for example, occurrence of dystocia might be there, or if not, what happens with, if it's only a weight, what changes? So that's as far as I know, and it's only a kind of circumstantial evidence, as you say, and this seems to be pretty consistent, that animals tend to be born heavier if they are born during winter, with the winter months. So that's something that I'm really interested in researching. But yeah, sorry, I don't have a kind of a very good answer.